I'm gonna just start this off. This really, really cool title that I came up with wasn't me. It was ChatGPT. I had to come up with something that was gonna, hook them and bait them. But all the concept and the ideas they're all mine. Just the title, that goes to AI. All right. So, what does disaster-proof data actually mean, right? Well, before we can know if data is actually disaster-proof, what qualifies as a disaster? Um, so, in the context of Kafka, right, a cluster failure can be a disaster. If your data center goes out, that's a disaster. Blackouts, as you can see here, right, New York City just wiping out, that's definitely a disaster. Um, and so, being able to architect your event, driven architecture and framework to be disaster proof is really critical. And what that means is, this really is important for use cases that need zero downtime. Those are use cases that have high level mission criticality. They need that business continuity and be highly available. You can see they're shaking hands and kissing babies, right? They look like they're important. So that's what zero downtime means. Okay, how do we actually accomplish this? Well, it's important that you have your data replicated, right? If you have all your data in one place, if it's located just in one position, that's not going to be great. I don't know if any of you guys are Rick and Morty fans here, but if you are, you probably recognize this GIF here with Mr. Mises, and pretty much they're all replicated. So there are the guys saying, "Hey, why'd you vote me in here?" Well, it was replicated from somewhere else and replicated from somewhere else, right? That's how the data needs to act in your architecture in order to be disaster proof, and it needs to be durable. So when one node goes offline, if there's a broker or anything that's affected, you have to make sure that there's something else that can be able to pick up that data. And so that's why I have the little kitten that's trying to find that node, and it keeps missing it because it keeps popping up somewhere else, right? So that's what durable data looks like. So a term that we use, multi-regional clusters, or also known as stretch clusters, is a way to actually architect your infrastructure for on-premise clusters. And this means that you have your brokers are actually stretched in different regions, but they share the same cluster, right? And so in this particular example, I just use some East Coast cities that I'm familiar with, right? You'd have your zookeeper, let's say in Philadelphia, and you have a region in Baltimore, another one in DC. It's really important that your broker is spread across different regions. And there are latency requirements, right? You necessarily can't have a broker in South Korea and another one in Australia and think you're going to have a stretch cluster. It doesn't work like that. Normally you want it to be about 50 milliseconds apart from one another. And so this is essentially how you can architect your clusters to have zero downtime, so that in the event that not just a broker goes down, but an entire region goes down, you have that resilience and durability. So multi-region clusters, right? Multi-regional clusters. How does that actually work, right? Well, there are three keys to disaster-proof data. Replica placement, where you have your actual partitions and where they're placed. We have these things called replica placement policies that govern that. And follower fetching, right? If you're familiar with Kafka, you're familiar with lead partitions and follower partitions, and making sure that you have followers being able to fetch your leaders. And then the real kicker here are observers, right? With observer partitions, these are essentially partitions that are not asynchronous, right? So if you're familiar with that term, min ISR or min in sync replicas, these aren't a part of that min ISR, right? They're observing asynchronously, but they're critical because if you have your replicas placement set up correctly, you'll actually be able to, in the event of a failure, have those observers be promoted to be a replica. So I'm actually going to go through a pre-recorded demo because I'm trying to get through things fast. So sorry if I'm getting a lot of information at you, but I want to be able to go through this demo, and then I want to get some questions at the end. All right, so this is a multi-regional cluster tutorial. And here in this particular tutorial, there are 4 brokers I have. I have 2 of them set up in East and 2 of them set up in the West region, right? And I was able to do that through the placement policy. So here we have a series of different topics, and they're named according to the replica placement policy that they have, right? So you have multi-region async and multi-region sync, and you can see here that there are followers and there are observers. And these are topics that have their own different placement policy in the multi-regional cluster. So here, when you describe the actual topics, you can see the leaders, and you can see the replicas and the in-sync replicas based on the actual placement policy, right? So for the multi-region async here, right, we have 2 observers, partition 3 and 4, which are in the East, and we have 2 that are replicas in the West. And then for the multi-region sync, these are all in-sync replicas. There are no asynchronous, there's no observers. So, that's why you see all of them in the in-sync replicas. So just want to give you a little breakdown there. And what we're going to do is we're going to actually simulate a failure. We're going to take down all the West brokers, and we're going to see how that actually impacts this multi-regional cluster. Yeah, so it's simulated. So essentially there's 4 brokers through Docker. And so it's pretty much specified as each brokers have in its own region, right? So you can see here we are actually, we're stopping the West brokers. And we're going to see once these are stopped, we're actually going to see how the Kafka topics, the architecture looks. And now we can see that in the multi-region async, where before we had 2 that were, in-sync replicas, and then we had some that were offline. So we had some that were observers, now we have some that are offline. And so what we're going to do is we're going to promote those observer partitions. We're going to promote them so that they're going to become replicas, and then we're going to, where we see that there's actually no leaders in this particular case. I do have this demo video, and I want to, anyone who is interested in seeing this fully be played out, I can send you the link, I can send you the deck. But essentially, you can see that there's no leader, and then I promote the observers, and then for these topics, and once we do that, that leader that was once none for the multi-region topic, now it has a leader, which is from the East region. So that's pretty much the conclusion of the demo, just showing how you can be able to promote observers and have that durability across different regions within a stretch cluster. Thank you, everyone, for your time.